Okay, in this video we're going to continue trying to mimic some of the functionality that Python has built in for us. And this is a good opportunity to practice your coding, but also to understand how some of the things that we see as pretty simple concepts can actually be a little bit challenging to code up. Alright, so what we're going to try to tackle today is the slice functionality. So let's make a new file here. I'm going to call this myslice.py, and I'm going to make my version of the slicing functionality that we see in strings and lists. Okay, so if you're on a Linux system or Mac OS, you can add the hashbang at the top, which will allow this to execute like a program instead of using the Python keyword at the beginning. And in order to do that, we need to modify the mode 755, so this adds the executable bit onto the file. We could alternatively use chmod, change mode, and add the executable bit like this, ls-al, and we see we have the executable bit. So all that does is allow us to run the program like this instead of like this. Alright, you need the hashbang and the executable bit. Alright, that said, let's make a function, and we can call it myslice. And so we're copying the name of the file here because that's the whole point of this file, is just to make this one function. And we might import this this file in another program at some point. We might want to use this function in some other program that we write, but that way we only have to define this function once, and we can use it in lots of other places. So that's a common thing in computer science. So I have this function definition, and I'll just pass on the implementation right now. If I think about how slicing works in Python 3, let's open Python 3 in interactive mode. So I can have a string of characters, and I use the square bracket notation, and I can put a colon inside. And to the left of the colon is my starting point, and to the right of the colon is my ending point. Right? So these indicate slices, right? So the 0 slice would be before the A, the 1 slice is between the A and the B, the 2 slice is between the B and the C, and then the 3 slice is at the end, right? So this should be right there. That is essentially, if you look at the thing we're slicing as sort of a loaf of bread, and the slices is where you're going to cut with the knife. 0 slice means you don't cut anything off. And then the slice that's equal to the length of the string, right? So this, the length of the string is 3. If that slice is equal to the length of the string, then that's not slicing anything on the other end, right? But here's the 1 slice, so we are starting at the 0 slice and we go here. So that's where we're cutting our loaf of bread here, and we should get those items. All right, and we run that, and we do indeed get that. There's also functionality to, if you leave one of the items blank, the implication is that we go to the very end of the string. Okay, so this is going to go from the 1 slice, just like we did before. Instead of explicitly using the 3, it's going to go to the end of the string. And this is helpful because we might not always know how long our string is, and this is always going to go to the end of the string. So a slice like this is always going to take the first character off. Alright, we can also do the same thing with the beginning. So if we leave that blank, that's always starting at slice 0. And of course this works for lists as well. If I want to convert this string into a list, I just use the list function, right? And it makes a list out of all the individual characters. So that's what I'm going to do. And I'm going to use the slice notation now, and we're going to go from 1 to 3, and now we're taking slices of a list. One thing to note here, when you have slices of a list, if I do something like this, this is going to take a slice of the list from the beginning to the end, right? So let's store this in a variable. We're going to store, we have li, we have list, maybe Okay, so if I just display list, right? This is what I have. Now if I take a slice of this list, li, from the beginning to the end, I get another list. So this is going to be li2. Okay, this list looks the same. Alright, now we can even say li, we can check to see is li equal to li2. They are equal. Now this equality is checking that the individual values in the list match. Right, so it's iterating through a loop and checking for equality on the individual items in the loop. But is it the same exact list as li2? So this is coming back false. This is operator is asking, are these two the same lists in memory? No, they're two separate lists, right? And I can show this by modifying one of them. So I can say the first item of li, we're going to change that and make that apple. So now li, we see has apple instead of a, but li2 still has a. So we see the lists, even though they contain the same items, they were actually separate lists, and that's the importance of the is. So when we are making our slice function, we are always making a new list. Okay, with strings it's a little bit different in Python. If the two strings are the same, they're always stored in the same memory location. It's not always the case with other programming languages, but it's actually an intelligent thing that Python does there. So another way we can look at this without having to modify a value, let's change li1 back the item at index 0, we'll change that back to a. And so now we'll check to see if li is equal to li2. That should be true again. Another way you can check to see if these two things are the exact same thing, which is basically what this keyword is doing. I can check the ID. So what's the ID of li and what's the ID of li2? This ID is essentially the memory address for where this thing is stored in memory. If these memory addresses don't match, then they're not the same thing. Okay, and that's essentially what that is operator is doing. So all of this to say, when we write our slice function, we need to make sure we're always creating a new list. All right, so let's exit out of here and get to making this slice. So what do we need to make a slice function? We have to have a thing to slice, right? So this is the thing that we want to slice up, and then we need to have maybe a starting slice and an ending slice, right? So how can we do this? We want to start with we can force the user to supply these two arguments, right? And then what we probably want to do is just start with an empty list. So this is going to be our results list, right? And we're gonna go from a starting point to an ending point from items from this toSlice object, and we're gonna add them one at a time. So how can we do that? Well, we can use the range function, right? Because this allows us to have like a starting point and an ending point. So it might help up here. Let's do a little example here. This is an actual code. This isn't going to stay in the file. I'm just playing around with code to demonstrate something. ABC. Okay, so this, let's say this is what we want to slice up. Okay, and then we pass in a starting string, and we'll say that might be 1. So we're going to say my slice. Might as well move this down here at the bottom. My slice ABC. We're going to have a starting index and then an ending index. Okay, so that means we're going to start here, and then the ending slice is going to be here. So how can we do this with the for loop? Well, we need to start with this item and add it to our results list. So the index of this item is what? Well, that's actually just our starting slice number, right? So that's convenient. So in the range function, our starting number can be 1, right? And then if we go, we want this range function to generate a list of items. So it's going to go from 1, and then we need to have 2 in the list. And then if we stop at 3, 3 won't become part of the list, right? And that's just how the range function works. Let's take a look in Python interactive mode again. If I create a list out of the range function, and if I go from 1 to 2, we have 1 item. So the ending is never included in the resultant list. What if I go from 1 to 3, like our example? We have a 1 and a 2, but that ending point is never included. Okay, if I go from 1 to 5, again, we go 1, 2, 3, 4, and the ending point is not included. The starting point is, the ending point is not. So that's important, and this actually works out pretty well because with the slice, the starting point is here. So that's the index we need. That's going to be I. It starts at index 1, and then it's going to go to 2, but then 3 will not be one of the items in the list, in the resultant list, right? So I will never be 3, which is good because the index 3 is outside the range of our subscriptable item here, right? Something at index 3 doesn't exist. There's only index 2 at C. So this is pretty convenient. We can just pop in the starting point and the ending point into a range function, and then we just get the results, and we append, so add to our list. What are we appending? Well, the thing to slice at index I. So the thing we're slicing up. So to slice is going to be our string ABC, right? But we want to grab the character at index I, right? And so this loop will run going from start to I will become start with, and then it'll end the last time through the loop where I is 1 less than the ending point. So this is going to go from 1 to 2. And so we're going to add the item at toSlice at index 1, which is B, and then I will become 2, and we're going to add the item at ABC at index 2, which is the letter C. And so by the end of this, we're going to have a list, right? So this is not quite the same thing as the string, but we can just return this list and see where we're at. Okay, we see there's actually not too much to this yet, right? This is sort of the core functionality, and there's not much to it. All right, so we can test this out. We're going to need to print the result so we can see what we get back. All right. And I will exit out of interactive mode, and I don't need to do that because we added the hash bang. So I can run the program, and sure enough, we get B and C. Okay, so that's effectively working, right? The only difference is it's made an array out of the characters, or a list out of the characters, instead of a string, right? So this would be good if we had the list version, right? If we pass in the list. So here I'm converting ABC to the list version. And so that's correct. But we need to say something in here. You know, if toSlice is a string, then we need to join all these items together, right? So we can do that. We can say if the type of toSlice is str. So remember, str is the function that creates string values. So in Python 3, I can do something like this, str, and take the number 12, and it converts it to the string 12, right? So this creates objects. So anything that's a string is actually of type this function. Okay, and this gets into object-oriented programming a little bit, and we'll be talking about that later. But for now, when you call the type function, right, and you pass in a value, the result is the function that was used to create this thing. And so in Python, if you have a string literal, that's considered to be created with the string function, right? So that's the type. All right. So here, if the type of the thing is string, then instead of just returning the results list, we want to return something else. We're going to return the results list, but we're going to join everything with the empty string. Okay, so the way this works is whatever character or string you have, that's going to join all of the individual elements of this array. So if this is A and B, and I put 2 hyphens in here, then the result would be A hyphen hyphen B. If this is A, B, C, D, right, I can change the input there. We'll move this list out of the way. We're going back to strings here. All right, so this is going to join all of the elements, right? So this slice should go from B to C. Let's make it go to 4, so it goes B, C to D. And remember, it was just in a list, right? But here, we're joining all of those elements in that list with this character, or these sets of characters. So if I have a hyphen there, we see I've joined everything in that list with a hyphen character. If I have 2 hyphens, every single element in that list is joined together using those characters. So if I want to join things together but not have anything in between them, I just use the empty string. So I join them together with the empty string, and then I've basically got my result. Okay, so this is the simplest sort of version that we can have for my slice. Okay, but the actual slice in Python does a lot more, right? So it allows you to do some interesting things. Let's look at if we have A, B, C, D, E, F, G. I can take a slice from 1 to 6. So that's 1, 2, 3, 4, 5, 6. Right? So that's going to be B through F. But then I can add an additional colon, and I can say I want to go up by 2 instead of 1. So this is the increment, basically. So this allows you to define a start and an end, and then also an increment. All right, this is just like if we think about what this might remind us of, we have the for loops. For loops using the range function, for I in range something, right? So in those cases, my terminal seems to have locked up. But in the for loop, right, for I in range, we can also add a step, right? So an increment number. And that's basically all this is. This is going to be an increment number. And for some reason my keyboard acted up, or my terminal. So we're going from index 1 to index 6. So that's the start is 1, the end is 6. So 1 to 6, but then we're going up by 2. So that means we're grabbing the first one and then skipping C, grabbing the one that's 2 up, and then grabbing F, right? So B, D, F. So we can implement that in ours as well, and we can have a step, right? And so the user, and we just pass in step here into the range function, and it should all just sort of work out for us, right? So there's continuity between the idea of slices and also this idea of the range function. So that's really nice that Python does that. So our step here should be 1. And let's go ahead and change this to A, B, C, D, E, F, G. And sure enough, we go from 1 to 4. Oh yeah, we need to go from 1 to 6 by 2. And we should see BDF as the result. And we do. Okay, so we just added that functionality, and it really wasn't that complicated. Now, one of the nice things that the slice function does is it allows you to not provide a start or an end, right? Or the step. The step is by default equal to 1. So if we don't want to provide that all the time, we'll just set a default value. Okay, and so if I don't provide this, then it just defaults to 1. If I do provide it, then it's 2. Right? If I provide 2, right? It could be 3 as well. Anything you might want. All right. So how can we do that with start and end? Well, if you don't provide the start, then that's definitely 0, right? Now the end is tricky because the end is always going to be, by default, the length of this toSlice item. So I cannot set, when I set, these are called keyword arguments, right? I'm naming an argument basically and setting a default value. So here for end, I don't want this to be 0, right? And I can't, I'm not allowed to add an expression here. I can't say length of toSlice, right? Well, I could, but I just don't have access to this parameter yet, right? This parameter is being defined on this line, and I'm not able to use it yet. But this is sort of ideal, right? This is what we would want the end parameter to be, right? And we can see if I try to run this, we're going to have an issue. Let's remove these. Right? So name toSlice is not defined, right? So we're in the process of defining this function, right? So this is technically not defined yet. So we can't reference it in here. So what we have to do is this sort of cheat, this sort of strategy where we're going to start this out equal to none. That's the default, right? And then once we get inside of the function, now this is defined. Once we're in the body of the function, we can use all of these parameters, but we couldn't before. We can't use them in the signature. So here I can say if end is equal to none, right? And it's only equal to none if the user didn't provide anything, right? Because that's the default value. But if the user provides something, then it'll be equal to that. All right? But if the user did not provide anything, so that means it's equal to the default value of none, then we're going to set that to what we really want it to be. So we're going to say end is equal to the length of our thing to be sliced. And so now we have some nice defaults. We start at 0, and then after this code runs, our end is defaulted to the length of toSlice, unless they provide other arguments. And then step we have defaulting to 1, which is the default behavior when we use the square bracket syntax. All right, so I can run this, and sure enough, my defaults all work. We can try it with a list. Okay, and that works. I can try it passing in slice numbers. We want to go from 1 to 6. Oh, I got that in the wrong parentheses. 1 to 6. Okay, so B to F. If I leave off the 6, it's going to go B to G. Now what if I want to leave off the end? Since these are arguments, if I want to just specify the end and leave off the start, so there's an implied 0, I can't really do this with this argument list, but I can with named arguments. So if I leave these unnamed, it's just going to be in the order that they were defined. So this first argument is going to coincide, well, so technically this is the first argument, which is going to coincide with the first parameter in the function definitions. This is the second argument. So remember, arguments are what are passed into the function call. The parameter is the variable name in the definition, right? So this argument is going to be stored in this parameter, right? But what if I wanted to leave this as the default and just specify end. Well, this is why in Python we have these named arguments, because I can do that if I specify end. I can say end is, I want it to end at 6. So this is going to go from the beginning of the list. So A will be included this time, but it should stop at F. All right. So that's what named arguments do. You can choose them. If you don't use named arguments, you can just specify these arguments as if they were, you know, normal arguments, not named arguments, right? But there's two benefits to naming your arguments. These are called keyword arguments, sometimes referred to as kwargs, like keyword for qu and then args, so kwargs. And there's two sort of benefits. One is you can, depending on your function call, you can just specify the one you need. You don't have to specify all of them. And you can also give defaults, right? So it's a very, very handy idea, keyword arguments. So remember that. And we can use those in lots of other functions. So what else does MySlice do for us? Well, let's think about what the Python version of MySlice does. Python 3. It works with negative indexing as well, right? So ABC, I can go from -3 to -1. Oh, yeah, sorry, that's not a comma, right? In our version, we're passing in arguments with commas. With the actual slicing syntax in Python, you use the colon, right? That was just a silly mistake. All right, so we see negative indexing, right? This is item at -1, -2, and -3. And so this the -3 slice, the slice is always to the left of that indexed item, right? So this is the -3 indexed item, so the -3 slice is here. And then -1 indexed item is here, so the slice is always to the left of that. So that should be these two items, and sure enough, that's what we get. So how can we support that negative indexing style? Right? Well, we can think of what does it mean to access, you know, this last item. So we have ABC, and we're just going to use, you know, the -1 syntax. This is just referenced by index, and that is the last item, right? So what are we really doing there? How does negative indexing work? Well, it's really just a shortcut for the length of that item, right? So if I have, you know, S equals my string ABC, all right, and so that's my string. I can say S -1, right, which is C, but that's really just saying the length of S -1, because the length of S is 3, and then subtract 1 is 2. So anytime you have the length of S -1, that's always the last indexed item. Okay, so when I have the S -1, that's really just shorthand for saying S length of S -1. But these two are the same thing, no matter what the string is. If it's -2, that's the same thing, -2. So there's just an implied length of S before the -2. So that's all that's happening there. So this is, it just saves us some typing. So we don't have to type this out. And if we change this variable name, we don't have to change it here too, right? So this negative indexing is just sort of nice. Python does this. Most programming languages do not, but it's kind of a nice feature. So let's add that. Let's see if we can add that here. Well, how's that going to work with slices? Well, it shouldn't be too much different, right? The idea here is if start is less than if either start or end is less than 0, we're basically just adding the length of the string to get the proper index, right? Because this is -2 index, if you add the length of the string, it's going to be the proper index. So S is ABC. Let's print out S again, right? And let's see S of -1. Right? We know this is that last character, but what is it? What's the positive index of that? So that's index 0, index 1, and index 2. So -1 plus the length of the string is 2. So really, if we just add the length of the string to whatever the negative index is, that should give us the correct index value, right? So all we have to do is we can specify a negative index for any of these, even, well, the start and the end. And if it's negative, we'll just add the length, and that should give us the proper value. So add the length of what we're trying to slice. Okay, so this is how you would support the negative indexing. So we're going to say if start is less than 0, that means it's going to be a negative index. Then start plus equals, can't type, the length of toSlice. And then we just do the same thing for end. And now we don't have to worry about it. So if it's negative, we add the length, and then we're back to start and end being the positive version of the indexing. And so if we're in the positive version of the indexing, then the range function should work. So let's try this. This is going to be -6 to -2. 1, 2, 3, 4, 5, 6, 7. Yeah, so this should probably be B to F again. We'll exit interactive mode. B to E, right? So yeah, so -2 index is going to be 2 characters over, but then it's to the left of that character, right? So that would stop at E. Right? So this is correct. This is working. So we have negative indexing. That's pretty cool. But what happens if we go too far negative or too far positive? If we have something like -12, right? That goes beyond our index. Now that's an interesting result, right? Is that what slice does? Python 3. So if I have A, B, C, D, E, F, G, and I take a slice -12 to -2. I did the comma thing again. There we go. So what slice actually does is if this index is too far past the beginning, it just assumes you're going to start from the beginning. And if this index is too far past the end, say this is 20,000, it just assumes it stops at the end. Alright, so we can do the same thing. We can say, so after we've accounted for negative indexing, we can account for indexing so I guess we could say overshooting the target, the start or end indexing. So to correct overshooting, right, we can just say if they provide an index, so we've already accounted for negative indexing here. So the index should be between the range of 0 and 1 less than the length, right? And if it's not, then we fix it. So if the starting index is less than 0, we just set it to 0. So if start is less than 0 now, right? Here, when it was less than 0, we just added the length to account for negative indexing, and that's fine. But now if it's still less than 0, then we're just going to set start back equal to the default value, which was 0. Okay? And the same thing for end. If end is greater than, right, our length of the thing to slice. So if end is greater than, let's see, that'll be greater than the length of the thing to slice minus 1, right? Because the largest index that's allowable, or no, it would just be the default. If it's greater than the length to slice, right, because that's the default value, then we just set it equal to the length of the slice. End equals length to slice. Okay, and so we've got a little bit of code commenting here. There's actually not a lot going on here, but we have added some nice features, and it mimics what my slice does. So let's run this, and we want to run it with we're overshooting here, so something like this. We're overshooting our index values, and it returns the list, so that's good. We can try it with strings. Okay, and that seems to work. So this is the basic functionality of sort of mimicking what my slice does. Now there's a lot we could add still to it. Like we could, if they provide the wrong item, right? We can only take slices of strings and lists, for example. If they provide something that we can't take slices of, we could throw an error. We can do all sorts of stuff. But this is just the core functionality of mimicking the behavior of Python. And again, this is just a good example. It's good practice. It gets you coding, and it helps you understand how these features that we use in Python, how they're actually implemented, right? So they're just niceties. In lots of other languages, you won't have slices, for example. So you'd have to write a function to do it yourself. But you can easily do that now that you know how it works, right? So that should be good enough for my slices. Next time we'll talk about maybe importing this into another file and then adding some test cases to make sure everything works really well.